All right. We want to thank the organizers for putting the paper on the program. Two of my co-authors are back there, Chatty and Kyle Dempsey. Kyle's going to take care of all the questions afterwards, and Victor couldn't make it. I'll just mention that these are our views and not that of the Federal Reserve Bank of Philadelphia. So we're all used to seeing a hump shape in earnings. So, the title is about inequality. So the left panel is across age on the horizontal axis. The blue line is the hump shape, the typical hump shape in income. The red line is in consumption. The inequality part measured by cross-sectional dispersion on the middle panel. You see that income inequality is rising across the age profile. Consumption inequality is as well. But what's not done a lot is kind of thinking about what the implications are of credit scoring. And so the black line is the mean credit score across the age profile. And even though it doesn't look big, there's an increasing variance of dispersion in credit scores across the life cycle. Okay, and so that increasing variance kind of is suggestive of maybe some learning going on, separation of types going on. And that's going to be at the heart of our paper. The other piece that we're looking at as well is that there's at the very beginning of life, the correlation between income and credit ranking is weak, and then it kind of grows, and then again, kind of levels off. That's we're going to be trying to think about how the income inequality maps into credit scores and hence access to credit and hence consumption inequality. Okay, so the questions our paper are going to be trying to resolve are: how does reputational inequality contribute to consumption inequality? How is reputational inequality? Again, this is just measured by dispersion in credit rankings. How is it affected by income inequality? How do signals about unobservable type contribute to reputational inequality? And what unobservables correlated with borrower risk are credit scores trying to capture? There's a wide view that it's kind of a proxy for character or conscientiousness in something like Ocean, the personality traits Ocean. I mean, John has some work on how self-control survey work, on how self-control can kind of map into conscientiousness. This is kind of, you'll see how we try to operationalize this in the form of a model. And some of the challenges are how to think about the links between reputation and income. And then finally, an important question is: how do changes in information technologies like big data, this is something that Stefania has worked on, or changes in regulation, like what's been going on with the CFPB, how does that contribute to consumption inequality? And so, like, who are the winners and who are the losers from pooling or separation of types of unobservable type? Okay, so this is going to be short. I just want to kind of give you a sense of how we might want to think about framing this question. So suppose that an individual has a credit score individual I has a credit score, that's the big S, that's observable. We're going to think that there are two kind of factors that go into making up a credit score. A person's income is going to be correlated with their actions in the credit markets. Credit scores use actions in the credit market to construct a credit score. But then there's potentially something else, like this noisy public signal about your unobservable type. It's an assessment of how creditworthy or conscientious you might be. And so, you can kind of think about using just this kind of logic to explain the data patterns in figure 1. And then the question about causal identification is really like, do these unobservable traits affect your income, et cetera? Okay. I'm not going to, I kind of feel like I'm not going to spend enough time on this because I don't have enough time. But when you kind of look at this picture, you kind of ask yourself, you see the income part coming down, but all the while you still see credit rankings going up. So there's some sense in which there might be there's something else, be it assets, be it this learning about your unobservable type that we're trying to get at. So that lets me get around this like my co-author wants me to do. Okay, so here's an outline of the talk. This paper is just a two-period version. It's a two-period adverse selection model, the simplest possible part of it. It's a simple version of our previous paper. The two-period is, in the previous paper, we had a perpetual youth model like Olivier's framework. Here, we had two unobservable types. There are going to be patient and conscientious low-risk people versus impatient high-risk people. There are going to be scores that are going to use credit market actions to learn or revise their posterior about people's types. We're going to introduce unobservable discrete choice shocks along the lines of the discrete choice literature, and that's going to help avoid lots of issues in perfect Bayesian equilibria about off the equilibrium path beliefs. It's also going to do, what it's going to do is kind of cloud the separation. I mean, if you can perfectly separate people via contracts, there's really no need to have something like a credit score, okay? Because you already know their type. So what are you assessing, okay? So this helps cloud that separation. Then we're going to kind of think about the correlation potentially between unobservable type and income. We're going to add moral hazard. And then we're going to kind of address some of the questions, the real world questions about what to keep out of a credit record. We're going to introduce medical shocks and then kind of think about what happens when you don't allow them, scorers, to condition on that. Okay, so here's the environment. Like I said, this is what we're doing. What I'll show you today is just this two-period model. As I said, Olivier's model is how we do it in that Econometrica paper. So there are risk-averse households. They're heterogeneous with respect to the unobservable type. So we're going to have two types. These types can move, the likelihood you're of a given type can move through time. In the current thing that I'm going to show you right now, we'll just have permanent types. It's a standard adverse selection kind of model. The type we're going to implement as patients, and that's there to capture conscientiousness. So we're going to have a high beta person versus a low beta person. If you kind of think about it, a high beta person, they're less likely to borrow. They care about their reputation, about the future, so they're less likely to default. So that's going to generate, the beta is going to generate the correlation endogenously between credit market actions, and that's what scorers condition things on. We're just going to take this really simple two-point process for income. In the baseline economy, that's going to be independent of a person's type. That's an assumption here, and we're going to change that assumption when we go to the moral hazard problem. The stuff that's blue is all like what's exogenous. The stuff that's red is what's endogenous. So people are going to choose how much wealth to accumulate or borrow. It's going to be in short-term risky assets. There's going to be a type score. It's just going to be like this public noisy assessment of probability that you're a high type. Okay, so and that that's so there's a psychology paper that these guys ran experiments, and they were able to kind of figure out people's or estimate people's discount factors, and then they found out people's credit scores, and they found a positive correlation between those. So that's kind of where this beta is kind of coming in, okay? And then there's, in this two-period model, we have to have a final, sort of terminal reputation, because by backward induction, there'd be no asset market. So that's going to be exogenous here in the sense of the marginal value of having a good reputation is going to be exogenous. In the end period model and in the Econometrica paper, that's all endogenized. And then on the investor side, there are risk neutral, deep pocketed creditors. They take the interest rate as given and make risky loans at a given loan price Q. It's going to depend, the loan price is going to depend upon how much debt you take out, and it depends upon these Bayesian risk assessments of your underlying type. Okay, so just to very quickly kind of think about what the timing is in this really simple model, individuals are going to choose their assets. Those assets are a signal, the credit market signal about your underlying type. Because remember, if I'm a high beta person, I'm going to act differently than a low beta person. Those choices are going to be subject again to these discrete choice shocks, and that's what's going to cloud that inference. That's why I call it a noisy public signal. Then there's going to be your borrowing allows you, and your income allows you to consume. At the beginning of the next period, there's a realization of your income. And then after that, if you took out debt, you have to make a default choice. Okay, so there's a default choice that's made. That's another public signal from the credit market about your underlying type. And again, there'd be Bayesian updating of that. And then finally, in the end, people consume, and then they, in the two-period model, there's some reputation benefit if you didn't default. Okay, so in this very simple adverse selection model, in the left-hand panel, remember, people at the beginning of the period are making decisions whether to save or borrow. That's a signal. That decision of whether to save, if I decide to borrow and low types are more likely to borrow, then it leads to divergence between what high types do and what low types do. The red is the low type decision, average low type decision. The blue is the average high type decision. Okay. In this particular case where there's no moral hazard, the income part is there. It's the same. Okay. So that's not going to be the reason for the divergence in the type scores. Okay. It's not the endogenous characteristic is not what's generating that. And then you can see differences in savings behavior or borrowing behavior changes the profiles of people's consumption. So, we want to kind of think about reputational incentives here. That's what, why do people pay back? I want to keep access to credit markets. And so, one question is, what are the consequences of restricting information in credit records? And so one way to kind of think of what I showed you before is the baseline, that's the world. But what if we restricted things and we said we cannot track your credit market behavior? Then we've just weakened all incentives to do good things. Okay. And what you see is it has a big impact. Weakening those incentives leads to less dispersion, less inequality. Okay. So, that's just, if you compare any line, whether if you think of standard deviation as inequality, you see that there's more separation that's going on. More, the incentive to separate leads to higher inequality in things like consumption. Okay, so what do we do next? Just we ask, how might unobservable type affect income? And so what we're going to do here is just change the exogenous income process that we had before, and we're going to let there be an endogenous kind of choice of whether or not to exert effort. Think about if a person has a high beta that and effort changes the growth rate of your income, then you have to incur the cost today. But if I have a high beta, I get a lot of return in the future. So that's going to endogenously generate a correlation between the type and growth rates in one's income. So that raises the probability that, just as you see here, it's like now we're finally conditioning on an effort choice. And the benefit is that you get a higher future income. And then this just, the right graph just kind of illustrates what we were getting at, that the high types are going to take more effort. Low types will take less effort. but it generates a higher income growth rate in the economy. Okay. Next, let's kind of think a little bit about medical expenditures. So there's survey evidence that unexpected medical expense shocks are a major reason for delinquency. What this CFPB and survey evidence has found is that the medical debts have little predictive power about borrowers' ability to repay others, and that consumers, part of the rationale for this is consumers frequently report receiving inaccurate bills. So that provided a rationale for the CFPB ruling that excluded medical bills from credit reports and prohibited lenders from using medical information in their decisions. So we kind of take our model and use it as a little laboratory. We introduce these medical shocks. They're going to be independent of type, so it's just pure luck, pure bad luck. And then there are delinquency decisions that we add into the model, and that's conditional on your medical shock. And that's going to, again, feed back into your reputational incentives. So, the key thing, this is kind of a story, when you kind of think about it, if you restrict that information, you move things closer to a pooling equilibrium. Okay, so if you can condition on the medical shock and delinquency decisions, the people who actually go delinquent are going to face low prices, i.e. high interest rates. Okay. The people who don't go delinquent are going to face lower interest rates. And then the pooling would be bringing you, when you can't observe any of it, the pooling brings you somewhere in between. So some people are hurt and some people are helped. That's the standard kind of cross-subsidization kind of a story. But then you can, because we have a model, you can start to think about welfare calculations. And, the ex-ante gain from going, we actually find that people are made better off in this. And that is also because of the timing of your consumption profiles. Okay, so there's both insurance across states and across time. And that's what's happening here. It turns out, people want to push consumption forward, and even the high types. Okay, and so then they're even made better off by a policy like this. Let me kind of just wrap up in some sense with a summary of what you've seen so far. So, if you kind of think about the restricting of information, thinking of it as going from the baseline to where you can't track, and even the observable to unobservable medical records, they both are restricting information. But the two cases are very different in terms of their reputational incentives. The baseline case where, and versus the no tracking world, no tracking kills all the reputational incentives. So my actions in the credit market affect my type score. My type score is going to affect my future value. Okay. That's beyond just in some sense, standard macro models tend to focus on this. Okay. What we're adding to it is kind of thinking about this. Okay. Same goes for the moral hazard part. If I take effort, that affects my consumption, my profile of income, that affects my value of reputation ultimately, and hence my welfare. Okay, so how big this in a general model, this is that fee that we put in just to kind of get at reputation. But in a general model, that's all endogenous, and that's what we do in other papers. Okay, so in conclusion, we have the framework actually extends to more periods. That lets us relax that exogenous reputation, and then we can use it to evaluate the role of reputational inequality and income and consumption inequality over the life cycle. It provides a laboratory to evaluate the role that information technologies and restrictions on scoring play in welfare analysis. And I guess I want to, we feel like there's an interesting and important methodological contribution that can be used from this. And it's just, a simple way to model dynamic hidden information problems. These extreme value shocks, which we've had since McFadden, they help deal with off the equilibrium path beliefs in perfect Bayesian equilibria. I think that's an important contribution to the theory. And it's still, this retains, depending upon your assumptions about what is observable, the model is very simple to use because there really is a block recursive structure to this. So it's easy to compute. Okay, thank you.